I am changing something in this question because this question have some mistake. Here is the mistake in the question. So I am just changing it. Here you will write positive, okay, and here you will write negative. Okay. So just start now. Where is positive? Negative and positive. So read the question first.
The potential difference across the terminals of battery is 10 volt when there is current of 3 ampere in the battery from the positive to the negative terminal. When the current is 2 ampere in the reverse direction, the potential difference becomes 15 volt. What is the internal resistance of the battery?
Okay. Means we have to find the internal resistance. So they are saying we have a battery. We have a battery like this. This is the internal resistance, and if we have a battery, so I am supposing capital E is the EMF of the battery and small r is the internal resistance, and this is the positive terminal of the battery, this is the negative terminal of the battery. And if the current is flowing from positive to negative, if the current is flowing from positive to negative, then the value of current is 3 ampere. Value of current is 3 ampere, and the potential difference means difference of potential between these terminals is given as 10 volt. Given as 10 volt, you can see in the question. Okay, this is the condition first. This is the condition first given in the question. So Hamza, tell me, is this battery is in the charging condition or is in the discharging condition?
In the discharging condition.
Yeah, this is in discharging condition because the current is flowing from positive terminal. Current is flowing from positive terminal and terminating at the negative terminal. So this is discharging. And what is the equation of discharging for potential difference? What is the terminal potential difference in terms of EMF and internal resistance when the battery is discharging or cell is discharging? Okay, you can check in your notes. I have already written V is equal to E minus IR. This is the discharging condition. The relation between the potential, this is the potential difference, this is the EMF, current, and internal resistance. V is given as 10. E we have to find, means we don't know. I is 3 ampere is given, and R. So this is equation 1. And in the second case of the question, second condition of the question is that They are saying if you reverse the direction of current, if you reverse the direction of current in the battery, reverse the direction of current means the current is flowing in this direction. Now the current will flow in this direction. So this is the condition of charging or discharging, Hamza?
Charging.
Yeah, charging, because here the current is flowing from negative terminal. So this is charging. And what is the equation of potential difference for the charging? Uh, Equation means I am talking about the relation between the potential difference, EMF, internal resistance, and current. And current here is 2 ampere this time. This time the current is 2 ampere. So like when the charging, the terminal potential difference or the potential difference or the voltage is greater than the EMF, so you will write V is equal to E plus IR. You should know these two equations. And this time the potential difference given as 15 volt. V is given as 15 volt. So put here 15. E plus I is given as 2 and this is R. This is equation 2. Now you can solve equation 1 and 2. Just solve the equation 1 and 2. This is equation 1. This is equation 2. So can we solve both the equations? Just subtract this equation from this. Minus, minus, minus. 10 minus 15 minus 5. E minus E you will get 0. Here minus 3R minus 2R. It will become minus 5R. So here minus 5 is equal to minus 5R. What is the value of R, Hamza? What is the value of R here? This R, what is the answer of R? R will be like this, na? R is equal to
R is
5
equal
divided
to
by
5 by 5,
divided
0.
means
9, 1.
5 by 5 is 0. 5 by 5 is 1.
No, 1, 1, 1.
Yeah. You have to be present in the class, na? Forgot all the things. Now you are in a class of physics. Okay, so see, you have solved the question and you have got 3 marks. So I am taking another question of the board examination. So this kinds of question only you will get in your exam. See how the questions are easy, how easy questions are there. So read the question means 3 cells of EMF E, 2E, 5E having internal resistance R, 2R and 3R. And here is a variable resistance R shown in figure. They are saying find the expression for the current. So current is flowing like this. I am supposing the current is, this is the positive terminal, this is negative, this is positive, this is negative, this is positive, this is negative. This has an internal resistance R, this has an internal resistance 2R, this has an internal resistance 3R. Okay. And suppose this is a current flowing like this. And how can you find the current? Current is equal to equivalent EMF divided by equivalent resistance. What is the equivalent EMF? Equivalent EMF, you will add all the EMFs because this is a series combination of cell. Because this is a series combination of cell. We have already discussed this in the class. So just add E plus 2E plus 5E. E plus 2E plus 5E. And what is the equivalent internal resistance? You will add all the resistance R plus 2R plus 3R. You will get 6R. And if you want to find the total equivalent resistance, then you will write capital R plus 6R. Okay, here you will write capital R plus 6R. So this will become 8E divided by R plus 6R. This is the expression of the current. You have got 2 marks. This is 2 mark question. So in this way you can solve the question. Okay, Hamza, got it?
Yes, sir.
You have told me na you are getting problem in solving the questions. So first you
Yes.
should know which and first thing is read the question properly. Okay, and after that you have to identify which type of connection is this, parallel or series. This is series connection. We have discussed positive, negative of one cell is connected to positive. Okay, and after that we should know how to calculate the equivalent EMF in the series, equivalent resistance or internal resistance in the series combination. And for this question you can see you should know this equation. If you don't know this equation, how can you solve this question? Okay, so you should know this equation. Now I am taking this question. This question is based on the calculation, where here we will do the calculation. The calculation part is more in this question. So just see here on this question they are saying two cells of EMF E1 and E2 having internal resistance R1 and R2 given, connected in parallel. They are connected in parallel. Deduce the expression for the equivalent EMF. Actually we have to find the equivalent EMF and the equivalent internal resistance for this type of combination. Okay. And further, when you will read the question, equivalent EMF and the equivalent internal resistance of a cell, which can be replaced the combination between V1 and V2. Means they are saying simply find the equivalent internal resistance and equivalent internal equivalent EMF. So the equivalent circuit of this will be like this. You will connect a single cell. You will replace these two cells with a single cell and having a single internal resistance, having the equivalent EMF, having the equivalent internal resistance. Okay. So can you now find this cell is in the discharging condition, you can see. So you can find the terminal voltage of this. This will become EMF minus the value of current that is flowing, I into RE. Okay, so this is the equation 1. This is the equivalent equation of the circuit. Okay, and we have to find this and this. We have to find this and this. So now you can see in this circuit that this current I is dividing into two parts. I can be written as this I can be written as I1 plus I2. Okay, Hamza. See this current from here. There are two branches. Current is going in two branches. You can imagine this like a water. Here some water is coming. Okay, water is coming like this, and some water is going in this pipe, and some water is going in this pipe. So you can write for the current I is equal to I1 plus I2. Okay, so this is equation 2 you can consider. Okay, now for cell 1, see the cell 1, cell number 1. This is a cell number 1. And for this cell number 1, can you find the terminal voltage? Hamza, can you find the terminal voltage for cell number 1? See, this is the negative terminal, this is the positive terminal. And here the current is flowing from the positive terminal. So this cell is in the charging condition or discharging condition? Discharging condition. And for the discharging condition, how we will write the terminal potential of cell 1? E1 minus I1 into R1. Okay. And for cell 2, similarly you can write E2 minus I2 into R2 because cell 2 is also discharging. Cell 2 is also discharging. You can see from here. Here also the current is flowing from positive terminal. So now what you will do? And one thing, this is a parallel connection. So the terminal potential of both the cell will be same. This is the parallel connection. So V1 is equal to V2 is equal to V. Let's suppose. Okay. So you can write V is equal to E1 minus I1 R1, and here you can write V is equal to E2 minus I2 R2. Just focus here. I have written, instead of V1 I have written V, instead of V2 I have written V here. So now from here I will calculate I1 and I2. Okay. So for calculating I1 and I2, I will write this. See on this equation now. See on this equation, I am solving this equation for I1. So when you will calculate I1, you will get E1 minus V divided by R1. From here, when you will calculate I2, you will get E2 minus V divided by R2. So now we have I1 and I2. We will put this I1 and I2 in this equation. Put I1 and I2 in equation 2. So I is equal to I1 is this E1 minus V by R1 plus E2 minus V divided by R2. Now from this equation, we will calculate this V. Okay. So just calculate. This equation can be written like this. E1 divided by R1 minus V divided by R1 plus this can be written as E2 divided by R2 minus V divided by R2. Now I will take common here E1 divided by R1 plus E2 divided by R2, and here minus B I will take common, so I will get 1 upon R1 plus 1 upon R2. Okay. So now take the LCM, solve this equation, solve this part and this part now. So here the LCM will be R1 into R2, and here you will get E1 R2 plus E2 R1. Okay. Here is minus B, here you will get R1 plus R2 divided by R1 into R2. Okay. So Hamza, what now you should do? You should just multiply both sides by R1 and R2. Multiply both side by R1 and R2. And why I am doing this, you will get to know. Multiply both sides with R1 and R2. So this will become I into R1 into R2, and we will multiply in this equation, means here we will multiply, here R1 into R2 we will multiply, and we will have this. Okay. I can write the equation. This is E1 R2 plus E2 R1 divided by R1 into R2. Okay. This is minus V. Here we have we will multiply R1 into R2, and this is R1 plus R2 divided by R1 into R2. Now this R1 into R2 and R1 into R2 gone. This is gone. So we will have I into R1 into R2. We have E1 R2 plus E2 R1 minus V R1 plus R2. Now we have to find V. So what we will do? We will write this as I into R1 into R2 minus this term we will take this side. Okay. So this will become E1 R2 plus E2 R1 is equal to minus V R1 plus R2. When you will take minus common on both the sides, then you will get V into R1 plus R2 is equal to I. You will get this I E1 R2 plus E2 R1 minus I R1 into R2. Now, for calculating V, you will just divide R1 by R2 on both the sides. Okay. So this will become E1 R2 plus E2 R1 divided by R1 plus R2 minus I into R1 R2 divided by R1 plus R2. So this is our final equation, and this equation is the equation number third. Equation number third. Now compare equation 1 and third. Compare equation 1 and third. So what is the equation number 1? Equation number 1 is this. This is equation number 1 and this is equation number third. And now you can compare both the equation. Now compare. So V, and here V, E equivalent is this, R equivalent is this. Okay. So E equivalent you will get on comparing E1 R2 plus E2 R1 divided by R1 plus R2, and R equivalent you will get R1 R2 divided by R1 plus R2. So this is your final answer. Okay, this is your final answer. Just note down all questions, and I have told you you can get these questions on the portal also. Okay, so no need to write the question. You can take the question from the portal. You can just write the answer only. Okay, take the screenshot now. Because we have a limited time. Hamza, taken the screenshot. This is I am writing here. This is answer for the question 49. Okay, just take the screenshot. Taken?
No, sir, 1 minute.
Okay, fine. And you can get this question on the portal, because when you will write the question here and answer here, it will spend a lot of time, and we have a limited time. So actually this assignment is for you, not for me, but I am solving it for you. Okay, Hamza, just taken.
Sir, done. Can you scroll?
Yeah.
Done.
Okay, good. Just complete this question means. Okay,
Done.
very good. So now take this. Okay, fine.
Done.
Okay, now take the screenshot of question also this time. Okay, fine.
Done.
Okay, take this.
Done.
Okay.
Sir, this also?
Yeah, of course.
Done.
This also.
Done.
This also.
Done.
Okay, this one also. And one thing I want to tell you, the last question,
Done.
in the last question, uh, calculations are involved. So I want that you should practice this question. Okay. Okay. So we will start our topic, mixed combination of identical cells. Mixed combination of identical cells. And if you have any doubt in the assignment, then you can ask me. So I am just starting the mixed combination of identical cell. What we are till now, what we have done, we have just connected these cells in series, identical cells in series and identical cells in parallel. Now we will connect identical cell in series as well as in parallel. That is known as the mixed combination. So what I am going to do here, cell this topic is very easy. Means you can connect n number of cells here. Means like this. Means you have what I we have. Just see here. You have identical cells. All cells are identical. Written here identical cells. So means all cells have the internal resistance R and the EMF E. Okay. And this is one row. This is one row. In one row, n cells are connected in series. In one row, small n number of cells connected in series, and there are m such rows. M rows are there. M rows are there. Okay. And what I have done, I have connected an external resistance with the whole of this combination. This is the external resistance I have connected. This resistance is the external. Here is one row, here is second row, here is third, fourth, fifth, and there are m rows like this. Okay. And in one row, n cells connected are in series. Okay. So now, what is the equivalent EMF of this row? What is the equivalent EMF and what is the equivalent internal resistance of this row? So for this, so means here n cells are connected in series. The total equivalent EMF will be n times of E. You will add E n times. Same is the case with internal resistance. You will add internal resistance n time, because here you will add R plus R n time. Here you will add E plus E plus E n times. And all rows are identical. You can write here here you can write all rows are identical. Means in each row the equivalent resistance is this and internal resistance is this. So here also NE and NR, and there are M rows you have. So okay, now can you tell me what is the equivalent resistance of this circuit? What is the equivalent EMF of this circuit? This here now you can see this cell, this cell and this cell all are connecting in series na? Means here all cells are connecting in series. Now you can say that M cells of EMF NE and internal resistance NR are connecting in parallel. And please remember one point, as this is the parallel combination. So in parallel combination, the equivalent EMF will remain same. Equivalent EMF will be the EMF of a single equivalent cell. So equivalent EMF will be NE. So equivalent EMF will be N times of E, and as this is a parallel combination, so for the equivalent internal resistance you will solve this like this. Means you will add NR M times, okay, and from here you will get this. You will take the LCM NR, then you will add 1 plus 1 plus 1, and this you will add 1 M times. When you will add 1 M times, you will get M into 1 divided by NR. So from here you will get R equivalent as NR by M. This is the R equivalent here. Okay. Now draw the equivalent circuit, final equivalent circuit. Final equivalent circuit will be like this. Here a cell of equivalent EMF NE is connected and equivalent internal resistance R NR by M is there of that cell, and external resistance is connected like this. So can we find the current? Hamza, can we find the current from here?
Yes.
What is the value of current? Can you tell me what is the value of current here?
No, sir.
Okay. So current, when you will find total current, you will write equivalent EMF divided by the equivalent resistance. Equivalent EMF is this. This is equivalent EMF.
Yes.
So NE you will write. And equivalent internal resistance means you will add this resistance plus this resistance. So the value will be NR by M plus capital R. So the value of current is this, NE divided by NR by M plus capital R. So this is the current in the mixed grouping. And for the maximum current, if you want the maximum current in your circuit, for maximum current, what you will do, you will differentiate this. We will use actually maxima and minima. In 12th class, we have the topic in maths, maxima and minima. With the help of maxima and minima, we can find the maximum and the minimum value of a function. Okay. So di by dr equal to 0 we will put, and we will double differentiate this, and we will get this less than 0. So we will get uh, when you will do this, you will get internal resistance of the cell is equal to the external resistance. Okay, so you will get this nr by m is equal to r. So you can say, what is this? This is the internal resistance. This is the total internal resistance, and this is the external resistance. Okay. So in the mixed grouping, for the maximum current, the total internal resistance of the circuit should be equal to or comparable to the external resistance. So you can write here, for maximum current, for maximum current in the mixed grouping of identical cells, the internal resistance is comparable to the external resistance And what is the meaning of comparable resistance? Suppose you have external resistance of 0.5 ohm and internal resistance of 1 ohm. So means you can say both the resistances are comparable. Suppose you have external resistance as 100 ohm. You have this external resistance as 100 ohm and internal resistance is 1 ohm. So in this case, you will say R is much greater than R. Suppose if you have R as 100 ohm and capital R is 1 ohm. So in this case, you will say this small r is much greater than capital R. Okay. If this is the case, then you will prefer this series combination. Okay. We will discuss this in the question. So I am not discussing this here. We will have a question. So we will discuss there. Okay, Hamza. So now you can note it down. Take the screenshots.
Done.
Okay.
Done.
Okay, take.
Done.
Now this.
Done.
Very good. So we have seen that in the mixed grouping of cells, the current is this, and this is the most important thing in the mixed grouping. Why this is most important? Because the examiner can ask you what is the condition for the maximum current in the mixed grouping of identical cells. So you will say the internal resistance of a cell, the internal resistance of a circuit should be comparable or equal to the external resistance of the circuit. Then we will get the maximum current in the circuit. Okay, and we have discussed this in series combination also. In the series combination of identical cell, if we want the maximum current, then the external resistance is much larger, or you can say the external resistance is large, then we will prefer the series combination. Means if this is the condition, then you will prefer the series combination of identical cell. For the parallel combination, the internal resistance must be larger than the external resistance. Okay, you can read this statement. And for the mixed combination, you can say the internal resistance equal to the external resistance or comparable to the external resistance. Okay, so we will have this question now. Where is the question? Oh, okay, we will have this question. Okay, actually we have done half of the question, na, Hamza?
Yes, sir.
Hamza, have I told you the mixed combination already? Okay, okay, fine. So just see this question now. Okay, this is the question we have. 8 cells of 2 volt and 1 ohm. Just we are solving this question from the starting. Okay. So now see this question. Here 8 cells of 2 volts we have. Here we have 8 cells of 2 volts and 1 ohm each are given. Okay. How would you combine them? How would you combine them to get the maximum current in the circuit? If the external resistance is this, if the external resistance is this, or if the external resistance is this. So I am solving the first part. Means we have 8 cells, each of EMF 2 volt, each of internal resistance 1 ohm. Okay. So here for the first answer, external resistance is given as 100 ohm, and what is the internal resistance? Internal resistance is 1 ohm, small r is 1 ohm. So you can say the capital R is much greater than smaller r, the small r, then you can prefer series combination of cells. So you will connect all the 8 cells in series. Okay, connect 8 cells in series. When you connect the 8 cells in series, What is the equivalent EMF? Equivalent EMF means you will add the EMF of all the cell. Means you are connecting 8 cells in series. Okay, and you have each cell have the EMF as 2 volt. So what will be the equivalent EMF, Hamza? Are you getting my point?
What's that?
I am saying that you have 8 cells. Okay, you have 8 cells,
Yes.
and each cell have 2 volt EMF, and you are connecting those 8 cells in series. What is the equivalent EMF? See this. What you are doing? You are doing this. Means you
Sir,
have,
8 into 2.
yeah, very good. 8 into 2 means this will become 16 volt. Okay, this will become 16 volt. Very good. Now can we find the current? So current is, what is the current? EE divided by R equivalent plus R. What is the R equivalent? What is the R equivalent in series? You are connecting 8 cells in series. Think. You are connecting 8 cells in series and each cell having resistance 1 ohm. See here, you are just connecting 8 cells like this. Okay, and this is 1 ohm, this is 1 ohm, this is 1 ohm. So what is the equivalent internal resistance?
8.
Very good. 8. 8 ohm. And current is given by this. Equivalent EMF is 16, and this RE will be 8, and this capital R is given as 100. So answer will be ampere. 16 divided by 108 ampere. You can solve it further also. Okay. So first part is over now. For the second part, when you will see the question, the second part is that internal resistance is 1 ohm. We already know each cell has the internal resistance of 1 ohm. And external resistance is given as this 0.01 ohm. So can you say that this small r is much greater than capital R? So which combination you will prefer? Parallel. You will prefer parallel combination, means you will connect all the cells in parallel. You will connect 8 cells in parallel. Means you are connecting 8 cells in parallel. Okay. With an external resistance of R. And this cell have, okay. So now Hamza, can you tell me what is the equivalent EMF in this case? This is a parallel combination.
3.
Why 3? Means you are connecting 8 cells, but this is one cell, this is second cell, and each cell have 2 volt.
Okay, 4.
No, not 4. Because you, in parallel combination, the EMF will remain same. EMF will remain same. EMF will remain same, and it is equal to the EMF of the single cell. This value. Okay? 2 volt. See here now. You can see here we have this combination. Okay? One cell is connected like this, second is connected like this, and the equivalent EMF. What is the equivalent EMF? Equivalent EMF is the EMF of the single cell. So here is the case. Okay, 8 cells are connected in parallel. So equivalent EMF is 2 volt, and here 1 ohm, and one thing more here. What is the internal resistance of the circuit? Means 1 ohm, 1 ohm resistances are connecting in parallel. So we will write 1 divided by 1 plus 1 divided by 1, because internal resistance is 1. You will do this, you will get the answer 1, you will get the answer 8. Okay, 8 divided by 1. So equivalent resistance will be, internal resistance will be 1 by 8 ohm. And what is external resistance? We already know. If you want to find the current, what you will do? Equivalent EMF plus in total internal resistance plus external resistance. Equivalent EMF is 2 divided by RE is 1 by 8, and this is 0.01. Okay, Hamza, can you solve this? Just try this. What you will do, you will remove this point and you will get 100 here.
100.
And you will take the LCM here. 800 will be the LCM, and this will be 100 plus 8. This will be become 108, and you will get answer.
So 1 minute.
6.
I'll solve.
Yeah, 108. This is your answer.
Yeah.
Okay. Oh, fine. Now third part of the question is external resistance is given as 0.5 and internal resistance is given as 1 ohm. Okay, so you can say that this external resistance and internal resistance are comparable. So you can say R and small r are comparable, means they have some value 1 and 0.1. These values are comparable values. So for the if the internal resistance and the external resistance are comparable, which combination we will use? Hamza, we had just discussed. See here, for maximum current in the mixed grouping of identical cell, the internal resistance is comparable to the external resistance. So for maximum current, we will use, if the resistances are comparable, and for maximum current we will have mixed grouping of cell. Okay, so we will prefer mixed grouping. So mixed grouping means some cells you will connect in series, some cells you will connect in parallel. Okay, so some cells, we don't know how many cells we are connecting in series and how many cells we are connecting in parallel. Well, one thing is clear here. External resistance is equal to the internal resistance. Okay, in this case, the external resistance, external resistance is equal to the total internal resistance. So suppose you have connected n cells in series. You have connected n cells in series. like this. You have connected n cells in series and in a row. Okay, and there are m such rows. Means you have m rows like this. Okay, so you have m rows. So what I have told you, the formula of internal resistance in the mixed grouping, this is the formula for equivalent internal resistance. Okay, n r by m. If you are connecting n cells in series and m such rows are there, so R equivalent is equal to n r by m. Okay, and this R equivalent is equal to the external resistance for maximum current. We have discussed now. For maximum current, what is R equivalent? N by m into R. And what is R? R is 0.5. N we don't know, m we don't know, small r we know. And 0.5 is 1 by 2. So you can calculate here, from here m is equal to 2n. M is equal to 2n. This you can say to the equation 1. So Hamza, tell me one thing. If you are connecting n cells in a row and there are m such rows, so can you tell me that what is the total number of cells you have in terms of m and n?
M into N.
Very good, very good, very good, very good. So total number of cells we have 8 and this is equal to m into n. Now you can put m is equal to 2n into n. This m is equal to 2n. Instead of this m, I have put this 2n. So from here you will get n is equal to 2. Okay. How we will get 2? Just see this. This is 2n square is equal to 8. This is n square is equal to 8 by 2 means 4. So we will have n square is equal to 4. You will take under root. Then you will get n is equal to 2. Can you find the value of m? Can you find the value of m?
Value of M, yeah.
Yeah, yeah. What
We
is the
can
value
put
of?
N is equal to 2. 2 to the
Yeah,
4. 4.
yeah. Very good. Means you have m is equal to 2 into 2. That is 4. So m is equal to 4. Means what is the meaning of this? N equal to 2 means 2 cells you have connected in series in a row and there are m means there are 4 rows. Okay. So this combination will look like this. Okay. All the cells are identical, 2 volt and 1 ohm resistance of all the cells. And here an external resistance. What is the value of external resistance? 0.5 ohm is connected. So this is the final circuit. Means in a row you have connected 2 cells and there are 4 such rows. Okay, so what the meaning of n equal to 2 and m equal to 4 is this. So can you find the equivalent EMF? Can you find the equivalent EMF of this circuit? Okay, we can find the equivalent EMF. Hamza, do you have any idea about this? I have told you a formula in the mixed combination for the equivalent EMF is equivalent EMF is equal to number of cells connected in series and number of cells connected in series and EMF of one cell. So E equivalent is how many cells are connected in series? Here 2.
2.
And what is the EMF of one cell? 2.
2.
So what is the answer?
4.
4 volt. From here also you can calculate. This is 2, this is 2. 4 volt, it will become 4 volt. Here also in this row the equivalent EMF is 4 volt. In this row the equivalent EMF is 4 volt. Means in all the rows the equivalent EMF is 4 volt and all cells are identical and this is parallel combination. So you can say that the equivalent EMF will be 4 volt because this is a parallel combination. Okay, so equivalent EMF is 4 volt. So very good. And what is the equivalent internal resistance? What is the equivalent? If you want to do from the formula, then you can solve from the formula. Just I am solving from the formula. N by M into R. What is the N? N is 2, M is 4, R is 1. So you will get 0.5 ohm. R equivalent you will get 0.5 ohm. And from here also when you will calculate, okay, this is 1 ohm, this is 1 ohm, this will become 2 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 ohm. Okay, this is 1 ohm, this is 1 ohm, so this is 2 ohm. Means when you will find R equivalent, then you will write 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. Okay, this will become 4 by 2 and R equivalent you will get 2 by 4, you will get 0.5. From the formula also you can get the same answer and from the circuit also you can get the same answer. Okay, so this is from the formula and this is from the circuit. Okay, so now external resistance we have this. So can you tell me what is the value of current? What is the, just please find the current by yourself, Hamza. All things, all the things are in front of you, just find the value of current. What is the current?
Have to substitute in the formula.
Yeah, you will substitute in the formula or just remember one thing, current is always equivalent EMF divided by the equivalent internal resistance and equivalent EMF is 4 volt.
4 volt.
And what is the equivalent internal resistance? What is the equivalent resistance?
0.5 ohm.
0.5 plus 0.5. Why? Because RE is capital R plus RE. You will take the external resistance plus internal resistance for the equivalent resistance. Okay.
Yes, sir.
So what is the answer?
4 by 1.
4 by 1 means 4 ampere.
4.
So current will become as 4 ampere. So this is the case. So mark 1 star on this part, mark 2 star, because here you have to think a lot. But in this case, you do not have to think. You have to directly solve the question. Okay, just take the screenshot.
Done. Done. Sir, done.
Yeah, Hamza. Okay, fine. Take this.
Done.
Hmm.
Done.
Okay.
Sir, 1 minute. Can you do up?
Okay, fine.
Okay, done. 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 Done.
Hmm. Okay.
And 1 minute, sir.
Okay.
Done.
Okay. Now this is your final answer, 4 ampere.
Done.
Okay. So this question is a bit lengthy because in this question there are 3 parts, and so Hamza, I will recommend you to just revise your notes first and practice this question one more time. Okay, then your concept will be clear. When you will solve the question by yourself, then and only then you can solve the questions in the examination. Okay, so now Hamza, you can take a break of 2 or 3 minutes. Okay, fine.
Okay.
And after that we will continue for 3 minutes. You have a break. Hamza, hello. Hello, Hamza. Are you there, Hamza? So this is all about the mixed combination of identical cells. Means cells is completed now. Okay, cells is completed. Combination of cells. Hello.
Sir, I'm back.
Okay, you are here now.
Yes.
So have you understood? Means just let's discuss. Okay, no problem. We have just completed the topic, and I want then what till now what we have done. Okay, in the cells, what we have done now till now. First, we have completed the series combination of cells. Series combination of cells. After that, we have done the parallel combination of cells. Okay, and after that, we have done the mixed combination of cells, and accordingly, we have solved the numericals also. Okay, so this topic is completed now. So I am just starting the new topic, and this topic is, I will say, an important topic for your board exam. And this topic, when you will solve the numerical by using the Kirchhoff law, okay, then the questions become lengthy. But actually, why we are studying the Kirchhoff's law? Because there are some circuits in which we cannot find whether this combination of resistances or combination of capacitors or combination of cells are in series or in parallel combination. Okay, so there are some complicated circuit that we cannot solve by using the concept of series and parallel combination. So that is why we are studying the Kirchhoff rule or Kirchhoff laws. When the complex circuit, not the complex circuit, when we will see that in a circuit there are no possibility of the equivalent resistance or the uh, equivalent series resistance or equivalent parallel resistance, then we will use Kirchhoff's law, and accordingly we will find the equivalent resistance or equivalent current and equivalent EMF. So that is why we are studying the Kirchhoff's law. So Kirchhoff's is the name of the scientist. Kirchhoff's is the name of the scientist. He has given two rules or two laws. He has given two laws. Okay. So there are two laws of Kirchhoff. First law is Kirchhoff's current law. Kirchhoff's current law, or this is also known as junction law. First is current law, or this is also known as junction law, or this is also known as Kirchhoff's current law, KCL, Kirchhoff's current law or KCL. So this law is very easy and very simple law. So, and this law is based on the conservation of charge, based on conservation of charge. So what is this law? Suppose a wire is like this and a wire is like this. Okay, one wire is this, another wire is this, and another wire is this. There are three wires here, you can see. And suppose there are the currents accordingly. Here I1 current is flowing in this direction, and I2 current is flowing in this direction, and I3 current is flowing in this direction. And this is the junction of three wires. This is the junction of three wires. Okay. So according to this law, uh, this law, current entering the junction is equal to the current leaving the junction. Okay. So what is the current entering in the junction? Hamza? I1 plus I2 is the current entering, and what is the current leaving? I3. Okay.
Yes.
So you can write this as I1 plus I2 minus I3 is equal to 0. You can write the equation like this. So this law you can define in another way also. You can say that algebraic sum, and first define the direction. Okay, no problem. Algebraic sum of all currents, algebraic sum of all currents at the junction is 0, and for this statement you will take the direction of the current. If the current is entering to the junction, if the current is entering, you will take the sign of current as positive. You will take the sign of current as plus I. If the current is leaving the junction, you will take the sign of current as negative. So you can apply this here. So what is the current entering? Means if the current, you can say that according to this, the current at the junction, the sum of the current at the junction is 0. So what you will do, this entering current, you will take positive, and leaving current you will take negative. So both the ways you can apply the Kirchhoff's. So I think we should solve one question on this, then it will be clear to you and you will solve this question. Suppose this is the junction point O and in this direction 1 ampere current is going, and uh, here in this wire we don't know the value of current and we don't know the direction of current also, and here the current is entering 3 ampere and here the current entering is 2 ampere. So Hamza, just find the value of I. Just find the value of I. With the help of your notes, you can do this question. Just find and tell me the answer. And whether tell me this I is leaving the junction or entering to the junction. This question is very easy question, very basic. Okay, fine, Hamza.
Okay, sir. I'm back.
Yeah. Okay, now please try to solve this.
Sir, can you hear me?
Yeah, of course, I can hear you. Can you
Sir,
hear me?
sir, your voice is not coming. Sir,
Now,
your voice is not coming.
are you getting my screen?
Okay, now I can hear.
Okay, fine.
Some delay is there.
Okay, no problem. That we have few time, means we have just computer class. Means you can just solve this question and we will meet in the next class.
Sir, your voice is stopping and some delays there. It's stopping like a robotic voice.
Okay, just give me one.
Sir, which question should we solve now?
Okay, what are you saying, Hamza?
Okay, now your voice is coming fine. Sir, I was asking which question.
The Are you getting the screen or not?
Yes, I'm getting the screen.
So this question you have to solve. This question. Are you getting the question? What the question is?
Yes, the two
You
lines.
you have to apply this law. You have to apply this thing I have just told you now. First current law means current entering or current leaving or algebraic sum of the current at the junction is 0, and you will take entering current as positive and leaving current as negative. This is very easy question and I will solve this question. I want that at least you should try this question. If you are not able to solve, then I am here. I will solve.
So I'm not able to understand.
Okay, fine. Just see this. This question is quite easy. So, this is the junction point. Is it or not?
Yes.
Junction point of this wire, and this wire, and this wire. In this wire, 2 ampere current. 2 ampere current is going to the junction or leaving the junction? Going to the junction now.
Yes, sir.
3 ampere is again going to the junction, and I have
1
told
ampere
you
is going out.
1 ampere is going out, and entering current you will take
Positive.
positive, and the current going out
Negative.
you will take negative. And the current you don't know, you will not take this with the sign. And you know that at the junction, at this is the law, at junction total current will be 0. At junction algebraic sum of current is equal to 0. Algebraic sum means you will take the current with sign here. Here you will take the current with sign. Means this 2 ampere is entering. So you will take this 2 ampere as positive or negative. And this 3 ampere is entering to the junction. So you will take this 3 ampere as positive 3. Okay. And this 1 ampere is leaving the junction. So you will take this minus 1. And you don't know the sign of this current I. So you will write this as it is. So now can you find this value of I? So this I will be minus 4 ampere. And if the sign of the current is negative, so this negative sign shows that the current is leaving. Current is leaving the junction. So this I is equal to 4 ampere. So in this way you will solve the question. Got it or not? Hamza?
Yes, sir.
Just note it down.
Sir, done.
Okay.
Done.
Okay.
Done.
Okay, fine.
Done.
Okay. Just for me, just solve one question. Just one. This is wire. Here the current is coming like this. Here is 1 ampere is coming. Here is 2 ampere is coming, and in this direction 5 ampere. What is the current in this wire? Here I you have to find, and you have to apply the same. Means you at the junction you will take the summation of current is 0, and entering current you will take positive, and
Yeah,
leaving current.
5 plus 1 plus 2.
Very good. 5 plus 1 plus 2
Plus 2.
plus I equal to 0. You will
Yes.
get I equal to minus 8. Minus 8 ampere means this current is leaving.
Yes.
Minus means the current is leaving. So the current will be in this direction. The current will be in this direction. And what is the value of this I? Means 8 ampere current is flowing. 8 ampere current is flowing in this direction. Okay, Hamza. Now I think you have understood that. Okay, Hamza. I will give you the assignment, and please check out the assignment on the portal, and please try to solve that